Welcome everyone. In this video, we will see how to deploy an autonomous system inside a robotic simulation environment. For this purpose, we will use a simple and easy to understand machine learning technique called decision tree, Pioneer 3DX robot as our autonomous system, and the overall objective is to autonomously navigate the robot inside a maze for path exploration. To get started, make sure you have the following: Unix operating system such as Ubuntu, but you can repeat these in the Windows as well, Python, Copilia Sim, and the file specified in the GitHub download link. Make sure your operating system is up to date by issuing sudo apt-get update and sudo apt-get install commands. You can verify the Python installation by opening a terminal and executing the command python --" version. If you are using Windows, make sure the system environmental variables contain the Python installed location. Based on the packet manager, you can install the dependencies. In my case, I have the pip packet manager, hence I will use the pip install command. As an example, I will show you how to install one of the dependencies, SSH keyboard, but please follow the instructions and install rest of the dependencies. Now we are ready to complete the setup process. Inside the documents directory, I have created a folder called Project Lab. Inside that, I have two folders. First one has Copilia Sim software, and the other one is going to be downloaded from the GitHub as a zip file. After extracting the zip file, you'll have two folders inside the Machine Learning Autonomous System main folder under the Autonomous System folder. They are going to be called as Core Files folder and Source Code folder. The Core Files folder is going to contain the required algorithm files for our autonomous system. The Source Code file, on the other hand, is going to contain all the files that is related to our entire project. We will use the Core Files folder for the rest of our demonstration. We are going to copy 16 required files for our remote API bindings inside the Core Files folder. These files are needed for our Python algorithm to connect and communicate with the robotic simulation environment. Navigate to the Copilia Sim edu software folder where you have installed it. Under that, make sure you go to the specific Python related remote API bindings. In the similar location, you can also find under the lib folder the remote API.so file. Copy that. In my case, it is Ubuntu. If you are using Windows, you will use the remote API.dll file. We will do a quick test to ensure we are able to communicate with our robotic simulation environment. Open the Copilia Sim software. Open the maze scene file, which is downloaded from our GitHub link. Press play to start the simulation. Open a terminal and execute simple test.py file. If you receive the following message, then you have successfully completed the setup process. To deploy an autonomous system, we need to follow a minimum of 4 steps. First, we have to create the dataset. Second, we have to pre-process our sample dataset. Third, we have to build a machine learning model from our training dataset. And finally, in the 4th step, we have to instruct our robot to use the machine learning model that we built from our previous step for navigation and path exploration. Step 1. For creating our dataset, we need to execute control robot dataset create.py file. Each and every time when you hit a key, it will create a sample or an instance for our dataset. W for forward, A for left, D for right, and S for back. It is recommended that you help navigate the robot without hitting the obstacle walls, at least for half of the maze. Once you are satisfied with creation of all the sample instances, you can press Ctrl+C. This will exit the program and also save all your instances into the datasensor.csv file. Make sure to stop the simulation in the Copillia Sim software before proceeding further. Second step is to pre-process the dataset file. We do this by manually going over each of the sample instances and making sure the labeling is done correctly and removing any outliers. To simplify this process, I have already done the pre-processing and provided it in a file called data-unique-sensor.csv. At the very top, you can see the features that are derived from the left and right proximity sensors of the robot, and the machine learning class labeling is done in the final column called direction. Here 0 means forward, 1 means left, 2 means right, and 3 means back. For the third and fourth step, which is building decision tree machine learning model and deployment, first press the play button in the Copillia Sim software and then execute the control robot autonomous decision tree.py file in a terminal. This uses the dataset we prepared in our previous step. In the first portion of this file, we are building the decision tree machine learning model and visualizing the model as a decision tree diagram in a PNG file format. Next, we are instructing the robot to move forward, left and right using the machine learning decision tree model. To check if our machine learning model is able to navigate the robot to the target location, we are using the following code. Once our robot reaches the specified target location in the maze, the program automatically stops the execution. Hooray! We have successfully deployed an autonomous system using the machine learning decision tree model. Nice work, everyone. Please note that this video is for beginners to quickly get started in autonomous system. It is not a comprehensive video. There are a lot of pitfalls that you have to watch out if you are planning to deploy it in a real-world application. For example, think about why we are using the laser detection range as a 0.75 meters, why we are using the supervised multi-class decision tree algorithm instead of other machine learning techniques. Did we carry out the pre-processing properly? Have we validated our machine learning model using proper testing techniques? In our demonstration, I would say using machine learning model is an overkill. We could easily achieve the same result with a simple if-else loop. However, the idea behind this video is to help beginners to start working on autonomous system and hopefully reduce the entry barrier. I hope this video was helpful. Thanks for watching.